Okay, so if we look down on this worksheet here that I just gave you at number 3, the first two that are, the first one that's on here, that's just standard form. We've already talked about that. 2 is something called intercept form. We'll do that one after lunch. I actually want to start on number 3. Because believe it or not, you already know how to handle this. This is just, remember taking the parent function and moving it around? You did it for absolute value, and we did it for the square root graph, and you even did it for these quadratics. So let me remind you of the pieces. The general formula is y equals a times x minus h squared plus k. So h and k is just the coordinate of your vertex. So HK is the vertex. So these are nice because you don't have to do any work to get the vertex. You can just look at it. You don't have to do negative b over 2a like you did in standard form. All right, so if I know my vertex and then A tells me everything that it told me before, tells me up, down, wide, narrow, so I still have all that information, same A as it was in standard form. Okay, so if I'm looking at this, where is my vertex? 1, negative 3. 1, negative 3. And now, since A is a negative 2, where can you go from here? So, for quadratics, I don't want to say that this is the slope, because it's not really, the slope is changing at every point on the parabola. But that does tell you how to get to your next point. So I'm going to go down 2 to the right 1. The problem is you just cannot do that. You don't do that again. The next time it's different. So we have a pattern when A was 1, right? We go 1, 3, 5. When it's 2, it has its own pattern. It's like 2, 6, I don't remember. But it's 2 and then 6. I don't memorize a pattern for each one. Honestly, I just do the first one. And then I just, if I need to, I plug in another value to find the next one. So, would you rather plug in 3 or negative 1? Because I'll get the same answer for either one. So it's your choice. Do you want to plug in 3 for x or negative 1 for x? Negative 1? Okay. So if I plug in negative 1 for x, negative 1 minus 1 is negative 2. What's negative 2 squared? 4. 4 times negative 2 is negative 8 minus 3 leaves me at negative 11. So 3, negative 11, buy 1, get 1 free. Also, you guys know that these should be coming out as parabolas. So if you're getting points that don't fall in line with the rest of the parabola, something's amiss. Maybe you had your vertex in the wrong spot. Maybe you plugged in that value incorrectly. But there is my beautiful parabola. And I could still ask you all those same questions. What's the equation of the axis of symmetry? What's the domain? What's the range? What's the y-intercept? Could you give me all that information? Yeah? So, vertex form, like I said, because you've seen it before, you did it with absolute value. It's just A is a little bit different because it's not really a slope, but it does kind of help you get to the first point at least. So, go ahead and try 4. See if you can graph 4 without me telling you how to do it. 4 is another one in vertex form. I don't totally love that this software has changed the grid to match. So every graph is going to fit beautifully on the grid that they gave you. I like on the last sheet, all of them were just the same, positive 8 to negative 8. So maybe your graph fits on there nice, maybe it doesn't. And when you're looking at all of these they're all the same width, so you can compare easily between parabolas. So on this graph, see how the boxes for 3 and the boxes for 4 are different sizes? So now, like, it's harder to compare wide and narrow. Yeah.
Because it's 4, -4, that's the vertex. There's no positive 4 and 10.
So that's a hint to you that you made a mistake. Isn't this worksheet nice? It's not positive 4. Because look at the formula, right? It's negative. So you really want -4, -4 is your vertex. That's what I'm telling you. This worksheet gives you too much information, in my opinion. I wish it was just a standard graph. So -4, -4, there's our vertex. Right? And then because A is 2, you can use this little trick. I can go up 2 over 1, up 2, back 1. But you can't do that for the next. Please don't go up 2 over 1 again. Now you're making a V. These are not V's. These are parabolas. There is a pattern for 2, but how about we just plug in the next number? Would you rather plug in -2 or -6? I agree. We just quickly plug in -2. 2 squared is 4, times 2 is 8. 8 minus 4 is 4. So when I plugged in -2, I got out of 4. Buy 1, get 1 free. Just reflecting over that axis of symmetry. Look at that beautiful parabola. Great job. Though I missed that dot altogether. Boop. That's better. So, what do we think about vertex form? Pretty easy, right?
That's a lot better.
Yeah, because you don't have to. It would be. How would you solve this? If I were asking you, like, say, take this one. Say I specifically asked you what the x-intercepts were. I know it's going to be between -2 and -3, and between -5 and -6. But what if I asked you where they are exactly? How are you going to do that with this one? You can, so that's an option. So you could FOIL this out, multiply it by 2, combine with the -4, and then use one of your 4 options. Solve by square rooting, quadratic formula, completing the square, or factoring if it does. However, there's a much easier way. So at the x-intercepts, y is 0, right? So I'm going to replace y with a 0. Does anybody see a super easy way that I could get the answer? I can solve this for x actually really easily without foiling that together and doing all that crazy work. No? Nobody? I can solve this by square rooting. Watch. Let's get the thing being squared by itself. So first I would add 4 to the other side. Divide by 2. I want to get the thing being squared by itself. The thing being squared is now by itself, right? So can I just square root both sides now? Yeah, you sure can. Square root of 2 doesn't simplify, but it is positive and negative. Over here, I just get x plus 4. And then all I have to do is minus the 4 over, right? So I would get x equals -4 plus minus root 2. So I would have to do the math out to figure out what those decimals are, but that would be my exact answer. That should work out, yeah? Oh, sure, go ahead. So just to show you, so one of my numbers should be between -2 and -3, and the other between -5 and -6. Let's see if I'm correct. So -4 plus the square root of 2. Well, what do you know? -2.58, blah, 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 blah. So there it is, in between -2 and -3, but that is my exact answer. So I know exactly where that thing is crossing the x-axis. It's at -4 plus root 2. And the other one, I know it's going to be -5 point something, but if I wanted to turn into decimal, I could. Yep, -5.414, blah, 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 blah. Cool. So, if you're asked for an exact, like exactly, where is this thing crossing the x-axis? Right there. What fun! So, Vertex form, not too bad, because I like that there's hardly any work up front, because you get the vertex right away. Oh, is that the last vertex one? Oh, I guess we'll just have to stop there. And then when we come back from lunch, I'll show you intercept form, and then I have more for you to practice. All right.